So we are starting EOT revision term 2 grade 9 advanced, and this is our first class for the exam revision for the term 2 physics examination. EOT question number 1. EOT question 1. It is about the horizontal projectile motion, right? Explain the motion of horizontally launched projectile and schematically components of velocity and acceleration throughout the motion, right? So first we need to explain horizontally launched projectile. Horizontally launched projectile, number 1, and second part is show schematically the components of velocity and acceleration throughout the motion, right? Show components of velocity and acceleration. And we need to discuss question number 7 and 8. Question number 7 and 8 from page number 147, right? Page 147. So this is the first question in the EOT. Explain horizontally launched projectile. So first we will explain what is the meaning of horizontally launched projectile. Can you give one example for horizontally launched projectile? Any example? Okay. Throwing a ball, right? Throwing a ball horizontally, right? Horizontally, yes. For example, if you throw it at an angle, it will be angular projection, right? It will not be a horizontal projection. Here you need to explain the horizontal projection, right? Correct, Ahmed? Okay. So what is the meaning of horizontal projection? Something you are throwing horizontally, right? Very good. Something you are throwing horizontally. For example, now I have a marker in my hand. If I throw this horizontally means along the x direction, right? Angular means it will, for example, this is the horizontal direction. If you throw like this, horizontally throwing. If I throw like this, it is making an angle, right? It is making an angle with the horizontal. That is angular projection. So throwing like this is angular projection. Throwing like this in the horizontal direction, that is the horizontal projectile motion. So you are top of this building and you are throwing the ball in the horizontal direction. You are throwing like this. From the building you are throwing like this. So horizontal projectile motion. So the ball will be moving along this direction, right? Like this, right? It will follow a curved path, right? Is that? Yeah, that we will discuss now, okay? About the velocity we will discuss. So this is the path, right? Okay. So first question, what is the shape of the path? Shape of the path. It's a curve, right? It's a curve. Okay. What is the name of the path? What is the path of a projectile is called? We call path of a projectile trajectory. Trajectory. Okay. Path of a projectile is called trajectory. Then we will talk about its displacement. In which direction? Displace means how is it displaced, right? How the object is changed its position. Is the object changed position horizontally, or is the object changed position vertically, or is the object changed position both horizontally and vertically? That we need to check. So what was the initial position of the object? Initial position here, right? So I will write for initial, and finally the ball is here, right? So we will write F for the final position. So you can see it was here, right? Now here, does this ball moved in the horizontal direction? You can see it was here, right? It was here. Before it was here on the top of the building. Now the ball is here. So it has a horizontal displacement, right? Yes. Yeah, it has, means the ball is displaced both along the horizontal and along the vertical, right? The ball was at this position before. Now the ball is here, means the ball has a horizontal displacement, means the ball has a displacement along the horizontal direction, and the ball was at this height. Now it is on the ground, which means by throwing the ball is displaced in the vertical direction also, right? So this ball has both horizontal displacement, both horizontal and vertical displacement, right? Horizontal means along the x direction, vertical means along the y direction. So what is a projectile? A projectile is an object which has both horizontal and vertical motion, correct? A projectile has both horizontal and vertical motion. Now we will talk about its horizontal and vertical motion, okay, separately. Here we will write a horizontal on the left side, and we will talk about all the properties of horizontal motion, and here we will talk about the vertical motion. Okay. So first, can you tell what is the force acting on this projectile in the horizontal direction? Okay. Yeah, I understand. You are telling in the horizontal direction, you are giving a force, right? You are giving a force, right? And you gave that force, correct? After you give the force, the object is not in your hand, right? The ball is not in your hand. It left your hand, right? So after that, is there any force acting in the horizontal direction? No. Like, for example, this is the ball. If I throw the ball, and if the ball is in the air, will there be any force acting on the ball in the horizontal direction? Will there be any force acting on the ball in the horizontal direction? Very good, perfect. Okay, if we ignore the air resistance, there is no force acting, right? So we will ignore the air resistance. No force is acting along the horizontal direction, right? No force. What about the force acting on this ball? For example, the ball is in the air here. The ball is here in the air. What about the force acting on the ball in the vertical direction when the ball is here? Very good, perfect, because earth is pulling the ball downwards, right? So force of gravity is acting. Force of gravity is acting. In which direction the force of gravity will be acting? Downwards, right? Force of gravity will be always acting towards the center of the earth. So force of gravity acting on the ball downwards. Downwards. Okay. So force of gravity will be acting on this ball along this direction, right? Force of gravity will be acting on this ball along this direction. So I will write Fg. Force of gravity is acting on the ball in that direction. Okay. Then next, if no force is acting, what about the acceleration of the projectile in the horizontal direction? Okay. No force means no acceleration, right? If no force is acting, no acceleration, so acceleration is 0. What about the force, what about the acceleration of this projectile along the vertical direction? 9.8, right? Acceleration is 9.8. So we will write acceleration equal to 9.8 meter per second squared, and the direction, acceleration is a vector quantity. It has a direction. The direction will be downwards, right? Okay. Instead of writing negative 9.8, I am writing 9.8 downwards. Negative just means the direction is downwards. Okay, so I didn't write negative 9.8, I wrote 9.8 meter per second squared in the downward direction. Okay, so if the projectile has both horizontal motion and vertical motion, right? Every projectile will have horizontal motion and vertical motion. So every projectile will have horizontal velocity and vertical velocity. Velocity along the horizontal direction and velocity along the vertical direction. Now we will talk about the velocity of the projectile. Okay, first we talked about the what is the force acting on the projectile in the horizontal and vertical direction. After that, what is the acceleration of the projectile. Now we will talk about what about the velocity of the projectile. So what about the velocity in the horizontal direction? It has no initial velocity means? No. See, you now you are telling about the vertical component of the velocity, right? Vertical velocity. Now we are writing here, what about the velocity in the horizontal direction? Perfect, very good. It will be constant. How do you understand it is constant? Yeah, it is constant, right? And you can see here the acceleration is 0, right? So if acceleration is 0, then velocity will be constant. Okay, then what about the velocity in the vertical direction? There is acceleration, so it changes, right? Acceleration in which direction? Downwards. So change means velocity will increase or decrease. Why velocity decreases? Velocity will increase, right? Velocity will increase because there is an acceleration in the downward direction and the object is moving downwards, right? See, the projectile is moving downwards, so velocity will be increasing. Velocity will be increasing. Okay, and see, this is a vertical motion, right? Sorry, this is a horizontal projectile motion, right? In a horizontal projectile motion, what about the initial velocity in the vertical direction? No initial velocity, right? Initial velocity will be 0. Why initial velocity is 0? Because you are throwing the object in the horizontal direction, means you are giving velocity only in the horizontal direction. So initially you are giving velocity only along the horizontal direction. So initially at the beginning, the projectile will have only horizontal velocity and its vertical velocity will be 0. So initial vertical velocity equal to 0. Okay, initially the projectile will have only horizontal velocity. Okay, so here we have only one equation in this side. That equation is we can write like a horizontal distance traveled, or distance traveled along the horizontal direction, that we will mark delta x. So delta x is equal to velocity along the x direction, means horizontal velocity multiplied the time, right? The time taken. Okay, so that is the only one equation we have in this side. And in this side you have three different equations. Do you remember the equations of motion? Vf equals Vi plus, continue. Very good. Acceleration multiplied time. Perfect. Then what about the second equation? Delta y equals initial velocity into time plus half multiplied acceleration into time squared, right? What is the third equation? Vf squared is equal to V, means initial velocity squared, okay, Vi squared plus 2 multiplied acceleration multiplied delta y. Okay, so when will you use this equation? The first one, you will use first one when yes, very good, perfect. Okay, so when no delta y in the question, no height is given in the question, you will use the first equation. When will you use the second equation? Because you need to check what is missing in this. So in second equation, what is missing? What is missing in the second equation? In projectile means in every motion, in equations of motion, you have 5 things, right? Initial velocity, final velocity, acceleration, time, and delta y, okay, displacement. So out of this 5, what is missing here in the second equation? See, Vf, right? Vf is not there, right? See, Vf in that equation, Vf is not there. So you will be using this equation when no final velocity in the question. And what about the third equation? What is missing in the third equation? Time is missing, right? So you will use the third equation when there is no time in the question. No time given in the question. Okay, do you understand this? Yes, perfect. So whenever you choose an equation, there should not be two unknown, right? There should be only one unknown. So you can use that equation to find that unknown. Okay, very good. Perfect, Ahmed. So now we have done first part, right? Explain horizontally launched projectile. So this one we have done now. Do you understand everything here? Do you have any doubt? Okay. Then we will do second one, show components of velocity and acceleration. So we discussed that schematically show, right? Schematically show the components of velocity and acceleration. The object has velocity in both horizontal direction and vertical direction, right? So first we will draw different position here, okay? One, first the ball was here, now the ball reached here. This is the another position of the ball and here, okay? So Ahmad, you can tell, first we will talk about the velocity, okay? We will draw the velocity. We will show velocity schematically. A projectile has how many velocities does projectile means how many velocity does a projectile have? How many velocities does a projectile have? Yeah, velocity in the horizontal direction and velocity in the vertical direction. So every projectile will have two velocity, right? Horizontal velocity and vertical velocity, or we can say two components. Every projectile will have two components of the velocity along the horizontal component and velocity along the vertical component, right? Correct, Ahmed? So here you can see at first this is the direction of the velocity, right? When the object was here, and when the ball is here, if you draw the tangent, this is the direction of the velocity, and when the ball is here, this is the direction of the velocity. When the ball is here, this is the direction of the velocity, right? So we will draw V, 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 okay? Before it just touches the ground, yeah, okay, leave it. Horizontal will be always same, right? So we will draw it as a components. We will draw it as components. So initially at the beginning, the object has velocity only in the horizontal direction, right? It has velocity only in the horizontal direction. So we will draw only one line here. Okay. Here it will have, when the ball reach here, it will have horizontal velocity and it will have vertical velocity. Horizontal velocity we will write Vx, vertical velocity we will write Vy. Do you understand? Up to here clear? Okay. Horizontal velocity will be always constant, right? So when we draw that, the length of the line must be same. This length and this length and this length must be same. Vertical velocity, what is happening to vertical velocity? Vertical velocity is increasing, right? During the motion, vertical velocity increasing. So we will increase the length of the vertical velocity. If here vertical velocity is 0, now vertical velocity. Here a small vertical velocity, now vertical velocity increased. When projectile reach here, it will have both horizontal velocity. Horizontal velocity will be always constant, so same length, and vertical velocity will be increasing. So the length of the line is increased. This is Vx, horizontal velocity, Vy. Vx, horizontal velocity, Vy. So velocity will be like this, okay, along this direction. Is it clear? Any doubt? Okay, so we have discussed this section, okay. Show the components of velocity along the means components of the velocity of the projectile. Now we will talk about the acceleration. I will erase this, okay. I will erase this velocity part and now we will talk about the acceleration. Yes. Which one? Yeah, because many concepts given, right, and projectile motion is little, means we need to explain little more. Yeah. So what about the acceleration? How will you draw the acceleration? How will you show the acceleration of the object? Yeah, if if there is acceleration, you are telling acceleration is increasing, right? No, that is not correct, okay. The length of the acceleration will not increase. Why there is acceleration? There is acceleration because of force of gravity, right? Force of gravity depends on the mass of the ball, right? Mass of the ball will be constant because you can see the equation of acceleration. Acceleration is equal to force divided by mass, right? What is this force? This force is force of gravity, right? Force of gravity of the ball will be always same, right? The weight acting on the ball will be constant, right, during its motion. The force acting on this ball, the force acting on the ball will it be same force or different force? Yeah, on the ball. Same force, right? It is same force. What about the mass of the ball? Will it be same or different during its motion? Same, right? Same force, same mass. during the motion? During the motion, force acting on the ball is not changing, mass of the ball is not changing, so acceleration will be same, right? Okay, so what is the direction of acceleration? Direction of acceleration will be always along the direction of the force, right? So force is downwards, so acceleration will be downwards. And the length of the acceleration means length of this line must be same, not longer, same length. Okay, acceleration must be same length, because acceleration is constant. Acceleration you need to draw, when you draw the acceleration you need to draw same length. Why same length? Because acceleration is constant. So when you draw it, you should draw same length. Okay, Ahmad, is it clear? Okay, then next we will discuss these two questions, question number 7 and 8 from page number 147. Can I erase this all? So I will ask a very simple question. You are here on the top of this building, and you have two balls here. One ball that you are throwing, as we have discussed. This ball you are throwing with a initial velocity in the horizontal direction. And you have another ball, the second ball. Second ball you are dropping. Okay, there is another ball here. The second ball that you are dropping. So the second ball will be moving along this path. Is it clear? Okay, my question is, which one will reach the ground first? Okay, question is, which one will reach the ground first? You have three choices. Okay, blue one, black, then third one, both reach at same time. So you have three choices to answer. Which one will you select? Yeah, one you dropped like this. Okay, this ball, the black one you are dropping like this from the top of the building. At the same time, another one, the blue one, you are throwing like this with an initial velocity. Yes, blue one has a velocity. Which answer will you select? You are selecting this one, right? You are selecting the blue one, right? You are telling that a blue one will reach the ground first, right? Okay, why? What is the explanation for that answer? So your question means your explanation is because it has horizontal velocity, right? Velocity along the x direction, right? That's your answer, correct? But the actual answer is, the answer is both will reach at the same time. Okay, this is the answer. This is not correct. This is not correct. The correct one is both balls will reach at same time. Okay, the explanation is here. You can see to reach the ground, it has to travel same vertical displacement, right? It has to travel same height, right? Correct. So both the ball has same acceleration, right? Both the ball has same acceleration in the vertical direction. So both the ball will reach at same time. And we can say like this: vertical motion and horizontal motion, and horizontal motion of a projectile, they are this ball vertical motion and horizontal motion of a projectile are independent. They are independent. Independent means horizontal motion or vertical motion will not depend on the horizontal motion. Vertical motion of a projectile will not depend on the horizontal motion. For example, you take another ball, your third ball, that you are throwing very fast and it is going like this. The fourth ball you are throwing faster than the third, it is going like this. All will reach the ground at the same time because it does, the time taken does not depend on the horizontal velocity of the projectile. Do you understand? Okay. The next day, for example, this is the ground. Okay, you are throwing two balls. One ball you are throwing slowly. So if you throw it slowly, so it will, for example, at this okay, it will move like this. The one you are throwing faster, another ball, okay, the second ball that you are throwing faster, it will move like this. Do you understand? Okay. So here, this black one, okay, the black one, to reach here, it is taking a time of 1 point, or I will give you 0.7 second. Okay, 0.7 second. What will be the time taken by the blue one to reach this point? Same height, okay, same height like this. My question is, see, the time taken by the black ball to reach this position is 0.7 second to the, then what will be the time taken by the blue one that you are throwing faster to reach this height? Same. Very good. So why it is same? It is same because both are traveling same height, right? Correct? Same vertical distance, right? Both are traveling same vertical distance. So the time taken will be same. Okay. For example, here you are standing here with a bat or anything. You are standing here, this position. You are standing here, okay, at this position. Yeah, see here, you are standing at this position, right? 0.7 second, right? Correct? So here, for example, the ball is reaching on your foot, right? Correct? The ball is reaching. The ball is falling at the foot, and here you can see, means here the ball is, this is your head. Here the ball is reaching, or the ball is falling at your head, right? Correct? At your head, correct? Yes, okay. So why the ball is falling at your head? You can see here, this ball is taking, means it is, the blue one is moving faster, right? The blue one is moving faster, correct? As the blue one is moving faster, it is taking less time. It is taking less time to reach the person. A person is standing here, right? Okay. So to reach him, for the ball to reach him, both the ball has to travel same distance, right? Same distance in the horizontal direction, right? Delta x. Okay, to reach the person, for the ball to reach the person, both the ball has to travel same distance, right? Same distance in the horizontal direction. So which ball will which ball is traveling faster? The blue one is traveling faster, right? So the blue one will take less time to reach the person, and the black one will take more time to reach the person. No, I said the time taken to reach same vertical distance will be same. See here, the time taken to reach same height. This is the same height, right? So it will take same time to reach this position. See, see here, by 0.7 second, the blue ball is traveling more distance, right? The blue ball is traveling more distance in the horizontal direction, correct? The blue ball is traveling more distance in the horizontal direction. For what? To reach here, right? You can see here in 0.7 second, what is the distance traveled by the black ball? This distance, right? This much, right? Delta x, correct? What is the distance traveled by the blue ball in the horizontal direction? This much, right? Correct? It is traveling more distance because it is moving faster. So to reach the person standing here, which ball will take less time? The blue one will take less time because it is moving faster, right? So if it take less time, it will travel less vertical distance, okay? Less time means less vertical distance traveled. Okay, that is why it is reaching on the head of that person. So we will go to question number 7, okay, given in page number 147. I will read that question so you will understand what we explained here. Two baseballs are pitched horizontally from same height but at different speeds. The faster ball crosses the home plate within the strike zone, but the slower ball is below the batter's knees. Why do the balls pass the batter at a different height? The ball is passing batter at a different height. The reason is both the ball are traveling at a different speed. So as at a different speed, they take different time to reach the batter. To reach the batsman or to reach the batter, both the ball are taking different time. The ball moving faster will take less time, and the ball moving slow will take more time. More time means it will travel more vertical distance. So it will reach under the batter's knees, or it is reaching under the batter's knees. And the ball moving faster, it is taking less time. Less time means less vertical distance traveled. So here the ball is reaching the strike zone. It is not reaching the under the batter's knees.